All right, let's take some derivatives using the quotient rule. Now there are a lot of mnemonic devices, and you can find your own, for remembering the quotient rule, but the one that I use is low d high minus high d low over the square of what's below. And that reminds me that the quotient rule says to take the denominator, multiply by the derivative of the numerator, subtract the numerator divided by or multiplied by the derivative of the denominator, and put all of that over the square of the denominator. So in this first example, we have low d high. That's f prime of x is equal to cosine x times the derivative of sine x. And then we'll subtract sine x times the derivative of cosine x. And then that whole thing goes over cosine squared of x. Remember that cosine squared of x is really just a shorthand for the cosine of x. Take the result and square it. Okay, so then we can just evaluate the derivatives. This is cosine of x times cosine of x, so we'll end up with cosine squared x. And then it's going to be minus sine x times minus sine x, so I see some negative signs that'll cancel there. All over cosine squared x. I won't do anything with that yet. So I have in the next step cosine squared x plus sine squared x all over cosine squared x. And then if I remember my Pythagorean identity, cosine squared x plus sine squared x is 1, so this is just 1 over cosine squared of x, which is secant of x. And you may have already seen that the derivative of the tangent of x, which is what sine over cosine is secant squared of x. So this all makes sense. Okay, for the second quotient, the derivative is going to be the log of x times the derivative of 2x squared. So that's just going to be 4x minus the 2x squared times the derivative of log of x, which is 1 over x. And that's all over the square of the function log of x. So let's see if I can simplify that a little bit. It's 4x log x minus, let's see, some x's are going to divide into one another here, so I'll get 2x, and that's over log of x quantity squared. And that's about as far as I can go on that one. Okay, third example, 1 over 2 e to the x. So the derivative is 2 e to the x times the derivative of 1 with respect to x minus 1 times the derivative of 2ex with respect to x, all over the square of what's in the denominator, so that's going to be 4e to the 2x. So e to the 2x squared, sorry, e to the x squared is e to the 2x. The derivative of that constant is 0, so that whole term on the left in the numerator goes away, and I'm left with minus 2e to the x over 4e to the 2x. And I can do some cancellation here, the 2 and the e to the x, to get minus 1 over e to the x as the result. Then our last example is going to be, let's see, our derivative will be x times the derivative of e to the x minus e to the x times the derivative of x, that'll just be 1, all over x squared. So I'm going to end up with x e to the x minus e to the x all over x squared. And I can simplify this a little bit maybe by factoring out an e to the x. So I have e to the x times quantity x minus 1 all over x squared. And that's about as far as I think I can go with that one.